we're going to do some select review problems from topic 13 and 14, and mostly the evens. I'll throw in some odd ones. We'll have multiple videos, but these first problems, they're just asking us to identify whether these are whether they're linear, quadratic, or exponential. So you first need to know the distinction between those, and hopefully you do. So if you have a linear function, it's going to have a common difference. Common difference. Like so. Let's go down here. We have consecutive x values, 4, 5, 6, and 7. So plus 1, plus 1, plus 1. But what we're really looking at, we just wanted to make sure they were consecutive. The difference between here, we add 7. Between these, we add 7 and add 7. That is the difference between them. So 23 minus 16 is the same difference as 16 minus 9 and 9 minus 2. They have a common difference, so this is a linear function. Quadratic functions, they have a common second difference, and they're shaped like a parabola, either a frowny face or a smiley face. So quadratic ones, they'll have a common second difference, and spoiler alert, we don't have any here. Now an exponential function, they have, as we've discussed, a common multiplier. So some number that is being multiplied by every single time. And then another really helpful thing to know is that they have an asymptote, which is a number that a function approaches but never quite reaches. So let's look at a function real quick. On calculator, say real quick. So, for example, we could do 2 to the x power. If the power is just x, then there's this line, which we call the asymptote, right here, that this function approaches, but it never crosses. It never goes below this point. For this one, it never goes below 0. So it doesn't matter what we make our exponent. So if it's negative 4, that's just 1 over 2 to the 4th. So it's a really small number, but it's not going to be less than 0. So as we look at number 3 over here, we see that this is approaching an asymptote, and it's an exponential function. Hopefully you know it's not linear because it's not a straight line. But the difference between this, if this were quadratic, it would come back down, right? Quadratic would be parabola. But this one is not. It's not quadratic because it approaches this asymptote and it keeps going towards 0, but never quite gets there. And I'm pretty sure that this would be the equation negative 1/2 to the x power. You can graph that if you want, see if it matches that. Then number 4, school district enrolls 400 new students every new school year. So let's say RSD started with none. So then the next year, so year 0, first year they have 400 students. Second year they have 400 more. Third year they have 1,200. And so what's happening here is we're adding 400 every time. That's a common difference. And so this one is also linear. Numbers 7 and 8. We're just supposed to write the function rule, and we kind of give you the knowledge that they're all exponential. So that means we're writing a function in the form y equals a times b to the x power. And a is our starting amount. So a is whatever y equals when x is 0. So that's a. So So for this one, we know we're going to start with negative 100 times some number to the x power. And what is that number? Put it in parentheses here. Well, what are we multiplying by every time to get from one term to the next? It sure looks to me like negative 100 times 5 is going to get me there, times 5 times 5. If you didn't know, you could take the second term, divide it by the first term, negative 20 divided by negative 4, that's 5. However you get there, you get that that's 5, and if we plugged a 1 in there, 5 to the first is 5 times negative 100. You'll see that we've got a good thing going here. This is our equation that models the data in that table. Now let's look at number 8. You'll notice we don't know what y is when x is 0. It's not a part of our table. So let's look for the constant multiplier first. How are we getting from term to term? We're multiplying by 3. So on this one we know what b is, and we could use that to find a. We could just plug in a coordinate and solve for a. But another thing we can do is we say, okay, well, negative 2, negative 1, what comes next? 0 does. So let's multiply 270 by 3, and we'll get 810. So y equals 810 times 3 to the x power. And if you were to plug in, so you can just go to your calculator. Once you get your equation, go to your calculator and plug in an x value, 3 to the negative 4, and see if you get the right y value. So when I plug in negative 4, 3 to the negative 4th power, times 810, I get 10. And that's what I'm supposed to get. When x is negative 4, y is supposed to be 10. So you can check yourself on these. There's the first handful of problems. New video coming with some more.